In this video, we'll be discussing quadratic functions in the form f of x equals ax squared plus bx plus c, which is called standard form. So in class, we discussed several properties of quadratic functions that include whether, just by looking at the function in standard form, whether it opens up or opens down, its parabola opens up or opens down, whether it has a minimum or a maximum, whether it becomes wider, whether it becomes more narrow, is it flipped upside down, and it has x-axis reflection, and also where the y-intercept is and how to find the vertex and axis of symmetry. So I'm going to walk through one example using y equals -1/2 x squared plus x, going over really what a quadratic function is. It's anything that can be written in this form. We did put one restriction on it, and that was that a could not equal 0. So we have to see the x squared term. So the a's, the b's, the c's could be any number. So b could be 0. C could be 0, b could be 1, c could be 1. They could be -17 or -17/3. The only restriction is that a cannot be 0. So you do have to see an x squared. Okay, so moving on to our example. Y equals -1/2 x squared plus x. So part A wants me to determine whether it opens up or down. So I'm going to tackle it one piece at a time. So A, one of the properties that we chose to cover was discussing whether it opened up or down. And so since A equals -1/2, and that is less than 0, that means it is going to open down. Alright, I'm also going to pick out my B. B is 1, it's a hidden one, and C, you don't see it, but it's 0. Alright, we're going to just use those later, so I'm going to write out those constants and coefficients. Alright, so since it opens downward, I'm going to draw my picture so that I kind of know what it should look like. It will have, the vertex will be a maximum. Alright, part B, we need to find the vertex. In order to find the vertex, this will be a point. I need to find my x value first. So the formula for the x value is the opposite of b over 2a. So we said b was, alright, so b was 1, so the opposite of 1 over 2 times -1/2. So that becomes -1 over -1. I would be careful about how you deal with fractions. Different problems will yield different results. Right, -1 divided by -1 is 1. So at this point, we know that the x value for our point is 1, and we need to find the y value. If you have an x value, substitute that in. So -1/2 1 squared plus 1. Alright, I would be conscious and use as many parentheses as you can, just to make sure. So -1/2, and 1 squared is 1 plus 1, so that becomes -1/2 plus 1, and that's a +1/2. So officially my vertex is, I'm going to put a V so that I know, 1, 1/2. Alright, and then part C here. Part C wants you to find the axis of symmetry. The nice thing is that the vertex always falls on your axis of symmetry, and this is the formula for it. So C, x equals 1. That is my vertical line that's going to allow me to reflect some points from one side to the other to create this picture. So to graph, first I'm gonna write a couple steps as suggestions. You don't need to memorize these or anything. I'm gonna plot my axis of symmetry. So x equals 1. I'm gonna move to 1. on my x-axis and draw the vertical line through it. Alright, step 2, I want to plot my vertex. Alright, which is 1/1/2. Alright, so that's going to be about right there. And step 3, I kind of want to put some arrows so that you know where it should end up going. So since it is negative and it opens down, I know that eventually I'll have a graph and have arrows down there. So that's what I want to do. Alright, step 4, T-chart. Alright, so I need to find some other x and y values so that I can have multiple points on either side. So I'm going to put 1/1/2 in the very, very middle of my chart so that I can pick some values on the left and right. And if I'm smart about it, I'll just use my axis of reflection and cut my work in half. So one piece of advice that I gave you guys was to use your y-intercept if possible. So f of 0 is really nice to plug in. So you have -1/2 times 0 squared plus 0. And that's just going to give you a 0 for y. So 0, 0 is 1 point that you can graph. If you use your axis of symmetry and go the same distance from your axis of symmetry, you should get the point 2, 0. And if you were to plug it all in and using your property of substitution, then you could find f of 2. Alright, so I'm going to keep going to the left. I'll go -1. Alright, so -1, f of -1, using my original formula here, -1/2 times -1 squared plus -1. That gives me -1 times -1 squared is 1. -1 times -1 minus 1. So that's -1/2 minus 1, which is -1/2. Alright, I'm just going to put 1.5. Alright, so I can graph that. -1, -1.5. And if I were to do the same thing as I did before, using my axis of symmetry, I know that would give me 3. -1.5. 3. -1.5. And that's about all you really will have to graph for me. I would love 5 points if you can fit it on there. If you go a step further, that's just going to give you a more accurate graph. So why not? It's just additional practice here. So let's find -2 and 4. So I'll do f of 4. f of 4. Alright, so that is -1/2 times 4 squared plus 4. Alright, so it's -1/2. 4 squared is 16 plus 4. That's -8 plus 4. So f of 4 is officially -4, which would make -2. Y value, -4 as well. So I could graph that. -2, -4, and 4, -4. So then when I connect the dots with the smooth curve, you should get a nice parabola. Alright, and it's always very good for you guys to label your things like AOS, x equals 1, and your vertex, V, is 1/1/2. Alright, and labeling the individual points on the graph. These are just steps. I would definitely want you to label those two pieces on your graph. However, if you want to go above and beyond and label every single other point, that would be great as well. So if you have any other questions, please feel free to see me before or after school, email me, or Google and YouTube additional videos. I highly recommend other resources like Khan Academy, or if you find another math teacher online that has a great channel, please feel free to follow them and share their videos that you think are awesome. Alright, happy graphing!